Thank you so much. So let's get started. Or packet tracer for network automation session. All right, these are more or less things I wanted to cover in this session. We are going to talk a little bit about general concept of controller-based network management, or if I may, SDN, or at least one flavor of SDN approach to manage networks. Then we are going to get to know PT controller, which is the packet tracer interpretation of a network controller. We will go over PT controller features and kind of learn what this PT controller can actually do and which functions and features of a real network controller are supported in packet tracer simulation. And of course, as we are talking about software defined, there's definitely some programming involved. So we go over PT controller API and how these APIs can be consumed from within packet tracer as well as in the real world. And of course, we will also talk about the DevNet Associate course a little bit in the end, because these resources, they all come from the DevNet Associate course. Yeah, so that's about it for the slides. And I really do not have many slides for this session. I have mostly the demo. So most of the session will really be a demonstration. Hey, Simeon, can you just confirm that my packet tracer topology is visible on your side?
Yes, it is.
Okay.
I see your screen and I see the topology.
Perfect. So we are going to use this topology in packet tracer for this demonstration. And this is something I just took from the DevNet Associate course. It is basically based on a DevNet Associate course lab. So let's get ourselves a little bit familiar with this topology, what's actually here, and what are just basically some facts about this network. This network, as you can see, has 3 routers. These routers, they run OSPF version 2. There is no IPv6 implemented in the network at the moment. All devices, including these 3 routers, as well as these 6 managed switches, they are configured for SSH access with this username and password, Cisco and Cisco 123. We have static addressing on the left side of the network. So in this LAN, the addresses are assigned in a static way. And we have DHCP service running on the rightmost side of the network. The DHCP service runs on router 3. And these computers, they receive their addresses from there. There are no any VLANs here, so this is just flat, just one single LAN with one address space. So it's pretty simple network, and but it serves as a kind of scaled down copy or scaled down example of a real enterprise network. So let's see how this network works. Just at least some things are operational in the network. So I would just do a simple ping, let's say across the network from this PC1 to PC4 on 192.168.102.3. Let's see how it works. And did I make a, oh yeah, I made a typo, of course. 192.168.102.3. There we go. Okay, so this works. Of course, if you use packet tracer every day, you know why the first packet is lost. It's pretty normal. If I do ping once again, there will be no packet loss at all. All right, so it seems like everything is operational here. And let's imagine a situation. This is the network we are tasked with managing, and we may run many different network management tasks over this network, like gathering information from this network, as well as applying some configurations to the network, also monitoring things and so on. Let's imagine just one of the typical tasks, which is inventory of the network. Let's say we want to collect from all our network devices, just basic information about them. What is this device? What is device operating system version? And maybe device serial number. So things like that. How would I do that with the classic approach? I would probably need to just go one by one device after another, logging into each of them. Actually, I cannot do that because there is no console on the device. So I will need to go to admin PC, right? Let's try to really operate in this demonstration from this admin PC because that's the one which is where we are physically located, okay? So from this admin PC, I will need to SSH into a device. Let's say SWL1, that will be 192.168.101.2. I think it's like that with the login of Cisco. Oh, come on. I think it's the other way around. I need to put -L here, Cisco, and then the IP address. Okay, now Cisco is password is Cisco123 bank, and yeah, and we are there in the device, and now I should be able to run commands on this device. Let me see if I can. No, I cannot do that. Anyway, if I need to gather information about this device, so what I would do the show version command. I can right away use the modifier to the include only lines with this release word because that's what I'm most interested about. And here we go. I have my device version. So, and the next obvious step is what I need to do. I need to actually, can I do this in packet trace? Okay, forget about it. I will just grab the text file, right? And just an empty text file, and I will need to populate this text file with this information. So I will copy the name of the device. Oops, this did not copy. There we go. And then I will need to copy the version of the iOS. So I can do that. Yeah, so I made just one of them. And of course, this is a tedious task. It is very boring to do, to collect information in this way. And of course, I only did one computer. Oh, excuse me, one network device, but I have many. In this network, I have how many? I have 9 devices, but in a real network, I really easily can have hundreds of them to manage. And moreover, it's not just about, I just need to gather this information once and then all job is done for years to come. I typically would need to do this on a regular basis, like gather and collect this information, monitor changes in this information, so on. So this is a really kind of straightforward, super old school, console-based way, then you like SSHing into each device and managing it. So, of course, there is a better way, right? There is a way. There are multiple approaches how a network can be managed in an SDN flavor. You can have each device enabled with an API that would provide some information, and then you can connect to devices directly. Or you can implement controller-based networking in your network. And examples of such controllers in the real life are APKM, which is not existing anymore, but Cisco's flagship product is DNA Center. So in Packet Tracer, we also have a simulation of this network controller. So if I'll go to end devices, and over here, I can have this network controller. So let's grab this network controller and add this network controller to our network right here and connect it to our network. And let's try to put it together and make it work. I will put it in the same LAN with this example server, and let me connect it to my network with this wired connection to the switch. And of course, the next thing I will need to do, I will need to apply some basic configuration for this device. I will configure the IPv4 access. Let's make it 192.168.101.254, just the last address from this address space, with the default Class C subnet mask. And of course, I will also need to configure the gateway. The default gateway will be 192.168.101.1, this router IP interface. Yep. Yeah, so since now I think this PD controller should be online and should be reachable from the admin. Let's go back to admin. And let's try to ping our newly added device in this network, 192.168.101.254. Okay, in the meantime, while this is still pinging, let us see. Yeah, there we go. We have a response from the network controller. Let me also, not this one, let me also put a note here with this IP address, okay? So we just have it, oops, we just have it here for convenience. All right, so now our controller is connected to the network and we need to configure it, right? We can start this configuration from admin because this device by itself, it doesn't have any interface to configure. I will just need to go to my admin computer and launch my web browser over here. And from my web browser, I will just connect to 192.168.101.254. Oh, something is loading up, and we are welcomed at the network controller. The first step I need to do, I will need to register a new user account because there is no account here. We could make it the same as for SSH, but let's make something different because then we can distinguish what is the credential and what are the credentials to access the network controller. Let's say it will be admin. Bang, and I will repeat the same password. Yep, and then I click setup. Then I will need to log in with my newly created credentials. Okay, that's probably because I mistyped something. Yeah, there we go. Okay. Packet tracer network controller interface. It is really modeled after the real DNA center interface, so it shows more or less what you will be seeing on a real device. So it shows some basic information about network. Of course, everything is empty so far because we did not yet add any devices, any network infrastructure into our network controller. How can we do that? There is actually a couple ways to do that. If I will go under provisioning here, I can either add devices one after another manually. So this is possible. I just add device, put the IP address of the device, and that's it. But there is also a discovery process available, which can help to automate. So this network controller would discover network itself, find devices, and gather facts, gather information about these devices. But before doing that, I will need to set up credentials for my device access, okay? Basically, I will need to tell network controller which credentials to use to access my network devices. And for my network devices, if you remember, the whole login name for SSH is Cisco, the password is Cisco123bang. Where is this? Yeah. So I will use this Cisco here and password Cisco123. There we go. Okay, and I can put SSH access to my network. This is just some description for these credentials. Okay. So as credentials is created, I can now process and start a new discovery. I will need to select the discovery type. In this case, I will use CDP protocol, and I will need to, well, name the. I will need to name the first device I want the discovery to start with, and this will be as the. It will be switching properly. With this switch, right? SWL1, this switch which is closest to the network controller, to PT controller. So I will say SWL1, and the IP address for this switch is 192.168.2. 192.168.101.2. Okay, timeouts are all fine, and I will select these credentials I have previously created from this drop-down list. Okay, I click Add Now, and it starts doing its thing. It starts to and start explore the network and which device progress. This time, just homepage and see if we already have some information. Nothing so far, right? We have really. So it's one home device, and it found 3 managed network devices. So again, to explore the whole network, it will take some time, and it's more or less realistic timing. Of course, it really much depends on how many devices you have in your network, how complex it is, and things like that. But eventually, it should do its thing. If you have provided all the credentials, if you have full connectivity, it should. And CDP is enabled everywhere because this is CDP-based discovery. It should do its thing and find all the devices. And by the way, if you have noticed on this discovery interface before, I will not jump back to not disrupt this view, but there is also an option to use range for discovery. So you can just specify a range of IP addresses, and it will try to go over this whole range and explore and discover devices which are available. So it's done now. We have 6 hosts and we have 9 network devices, and I believe that's what we have in the network. 1, 2, yeah, we have 6 hosts except for the network controller itself. That's it. So we have some information. What we can see here, what we can do, we can probably go to assurance or check our provisioning. Okay, yeah. So that's under discovery process. It's still in progress, but it will end soon and stop discovering. But if I switch to the network device tab, I see the list of network devices that were discovered by the process. So it's not just the SWL1 from here. And get some extent. Anymore. See for a serial number and okay. Yeah, so have a key statistical information.
Hey, Eugene, excuse me, can I disturb you? Can I interrupt you? Your audio is breaking at some point. Sometimes not good, sometimes breaking a bit, sometimes breaking a lot. If you have any opportunity to disable something that consumes your bandwidth, I know the camera is already off, but well, just in case. If you have something to disable, could you please do it? Or maybe, yeah, well, I have no other ideas.
Let me try to switch to another network and hope this will help.
Let's see. Hello? Hello, hello, once again.
Hello?
Are you... Oh, okay, can you say something else? Hello, hello? I would say it's breaking still. No, it's breaking. I would say it's even worse.
It may be not my network. How?
Well, now it's not good. It was better when you was on the previous network. Yeah. Right.
Can you hear me already?
Hello.
Hello, can you hear me?
Yes, we can hear you. I can hear you. Well, I think it's better, but well, it was worse on your other connection. So, yeah, let's maybe just go on and well, see how it goes. If you have anything to disable on your PC to minimize the load for your, I don't know, whatever network or CPU, maybe that would help. Not very sure about it. No, don't do it. Right.
Right. Sorry about that, guys. Let's moving and see how I hope it'll be all fine. Yeah, we were just looking at this dashboard, right? And in this dashboard, we have, like as I said, just the basic high-level statistical information, more or less. So if we go to Assurance tab here, that's where I wanted to go. We see more detailed information, like distribution by the type of device, what is their general health, health information, and possibly under here we have hosts, which is very similar to this is like end hosts. So these are our computer. We have the computer system connected. See some additional details. One interesting thing you also can see here, it is the Topology tab. So in the Topology tab, in the Topology tab, it should show the Topology. Just try to, maybe it does need some time. Yeah, there we go. Yeah, this is definitely not a network issue. It's my computer a little bit. Let's see topology again. I think the process takes a little bit of resources from the computer, and somehow it doesn't work well. Okay. Yeah. I hope you can hear me. That's how the topology looks like. I can tell just from the produced here very slowly. It's just a shortage of resources on the computer, but that's what you get, right? So this is the topology you have, and if you compare it to the real topology we have in Packet Tracer, this is exactly the same, right? So we have these routers and we have these switches in the topology. Okay, then there is also a possibility to do a path trace, and path trace would trace the path or route between two different hosts or IP addresses in your network. You can create this path trace from source destination, then just observe how it goes, and then you can actually later use it. So let's do that real quick. In the beginning of the session, I think we did this trace between PC1 and PC4. I did this ping command, so I can also do the same from network controller. Then 130. 10.0.1.130, and the PC4 address was 192.168.102.3. Okay. So I have created this ping, and I can click it, or I should say path trace. Once I click it, I see the results of this path trace. It shows information about the stages or steps in this traffic progression from PC1 to PC4. All right, it goes through a few devices and some routers and so on. Okay, what else we can do? We can actually not just look what's available there in the network, but we can also apply some configurations. Under policy button here, I have a few options to go. I can add scopes and then apply policies here. And I can also apply some more basic network-wide settings. So for example, typical that I would have in a server in the network, right? Or AAA authentication server or NetFlow or whatever. So with network controller, I can apply the settings across the whole network. And let's do that. In my network, I have this sample server, which actually runs DNS, NTP, and syslog. Let's stick with these three: DNS, NTP, and syslog services. And this IP address is 101.100. Let's just configure this as a server. My domain name will be example.com. For example, yes. And the domain server address will be 192.168.101.100. Is it correct? Yes, 101.100. I will save this. I will also configure NTP. This is easy. This is just the server. It is the same IP address. 100. I will save it. And I will configure a syslog server as well with the same IP address. Okay. Interesting. And now my packet tracer crashed. Okay. I will have to restart it, I guess. And by the way, while my packet tracer starts, you can notice this is a very interesting version number on my packet tracer, right? Okay, I'll have to. Yeah, go ahead.
I was just saying, well, while it was starting, we could answer a question what version it is. It was we had this question in the chat.
Yeah, that's right. The version is 7.4 T, right? So if I go into the About tab, it's 7.4 T. T stands for more like an experimental train of this packet tracer. So this is not a normal packet tracer. This is a special version of packet tracer only available in the DevNet Associate course. Okay, 192.168, what was it? 101.254. That was the gateway. Let me configure the IP address. I did it wrong. No. That should be 1 here because that's the gateway, right? Okay, and now for the address device itself, 192.168.101.254. This is now configured. I will have to, well, I'll keep this one. I'll go to admin, desktop, web browser, and I will access my device. Okay. Again, I'll have to reset up. Username admin, password admin 123. And then login. This crash sources on my computer. That's actually why I have even the audio issues. So let's go back to provisioning, credentials, create credentials again. So username will be Cisco, password will be Cisco 123, like that. Okay. And I will start the discovery process again. So CDP, and the IP address of the switch was 101.2. And I will check credential at. So this will get populated again, and we will see go and apply the policy configurations. At least start applying them, and then once everything is done, we will push them to the server. Work. The domain name will be example.com. IP address will be 192.168.101.100. And it will be the full entity. I did not see this. Will be. Now, before pushing this configuration, one thing I want to do, I want to save my file in packet tracer. So this should save everything into all the controller state. And then I will push config and let's see how it works. Okay, push all network settings. I have this open view all the settings I'm pushing to the server, and then I click OK to implement that. And if I now review the settings, they are here, the saved. But let's not take the controller's word for it. Let's just jump into a device, let's say any device like R3, for example, and let's see if the network device configuration was changed according to this network-wide settings. So if I go to show running config and include whatever DNS, right? Okay, it didn't work somehow. Okay, interesting. Let's check for all network they are discovered. It's still not done. It's process. It was not applied to all of them. Okay, let's see what's going on under the provision tab. It's still before we pull this network. I was just rushing through this because of but I'm to fast forward time, and maybe this will do good for us. At least a couple times. And let's make it a learning experience. If you closely to what was happening, I did apply some network setting like DNS and stuff, but the network was not fully discovered yet. So let's check now on R3. Did it apply the configuration? No, I have to. All access. Or I'm because the name is here. Yeah, it actually did work. No, right. So it's a login command has appeared on the router, although this router joined the control domain even after the policy was set on the controller. So what controller does, it makes sure that your devices, doesn't matter if they're added into your network before or after you apply changes, it makes sure that devices are, they have actual configuration. All right, we can also show NTP associations, right? Yeah. Good. So what else? That's pretty much fine. If we look here under menu on this network controller, we also have very interesting part, which is API docs. So this network controller in Packet Tracer, like a real DNA center, it also has an API interface. You read this API documentation on the controller itself, and you can use this API, you can consume this API in multiple different ways. There we go. API can do through the API. It pretty much mirrors all the functionality you have in the controller GUI, and it has a few more things we cannot do from the GUI. To start working with API, you need to first use this ticket. You need to it will need to the controller username and password and receive a ticket return, and then use this ticket to authenticate your further requests to the PT controller. So let's do that. I mean, let's try to put together some small Python code that would work with our network controller and API interface, and that would lead from network controller. What I will do here, again, right now, you still remember I am here on the admin computer. All things I'm doing here is through the web interface, which is open on the admin computer. So from admin computer, I will go to programming tab, and under programming tab on this computer, I will create a new project. My network, mynet, that will be mynet, whatever. And I will use empty Python template, and then I can type in my Python code here. So I will quickly build code from scratch and paste some because we don't have too much time. But let's start with the basics. First of all, I will need to use the Python requests module. So I will import the requests module, and another module I will also need later on is JSON module. It is pretty, if you have seen any previous IPD sessions or just know, you have played with this at least a little bit, you definitely know what this is about. We are going to use this requests module, which will allow us to access this, to run this HTTP request to a device. Then I will create a variable, base URI, where I will put all my, not all, but I will put my URI for my request. This will be HTTP. Then the address of my network controller, 192.168.101.254/API/v1. So this will be the base. Then I will need to, when I actually use it, I will need to add something here. And this will be a specific API call for a specific feature, okay? For now, I will just keep it like that. And let's make our first request. Basically, of course, our first request should be to request service ticket. API call to request service ticket. Okay. And this request module in Packet Tracer works exactly in the same way as in the real Python. It is not real Python, but it is very similar experience. So first of all, I will need to send some headers to the device, to the API service. And the one header, and only one header I will need for this request will be content type, because I will be sending some data. And this data will be in JSON format, and I want to make sure that I indicate to the server that this data is actually coming in JSON format. Okay, and then I will also need the data itself, and of course, to request the service ticket, as I said, you will need to send your name and password to the API servers, and this has to be JSON data. All right, I can do it in two different ways. So let me first just this will be name, and username will be admin. That's what we did. You remember we created this user when we started this session in the beginning, and then password. And password will be, of course, admin123 Yep, and that's it. So this piece of information here, it is a Python dictionary, okay? But what I actually need, I need the same, but in form of a JSON string. There are two ways how I can make a string of Python dictionary. One is kind of a really lame way. I can just add single quotes or just quotes. on both sides. And now this is not a Python dictionary anymore. It is just a string with this set of characters. But there is a kind of a better and let's say more safe way on this. So basically, JSON comes, it will in this Python dictionary, it will make sure everything is fine, and it will provide guaranteed, well syntaxed JSON string out of it. Okay. Then I will need to basically execute the request itself. I will create a new variable which will have the information which will hold the result of my request, and I will use the requests.post function because this must be a post request, and I will use my base URI with edit small string there in the end /ticket. Look, in the documentation of this API, that's what I need to do. That's what the documentation says. Okay, so this will be the string to request, and then I will need to provide data, this thing, right? And I will need to provide headers. Headers. Okay. Good. So I need to fix some typo here, and then I can basically, well, this will be the execution of the request. So the next thing I will want to do, I will need to print the status code for my response. And if the status code, that would mean that everything is fine, or 200 or 201, 200 something. If not 200, then something is wrong. Let's try that. 201. Okay, so it works. It works fine. I will create a new variable result, and I will put the RESP.json in there. And RESP.json is basically the data which is returned by the server, and I will print this variable. Okay, let's run it again and actually see what is the response we get from this API endpoint. There we go. So we get some response. The response has what we need. It has this service ticket information. This is a specific ticket we need. Let's just grab this ticket. I will create a ticket variable, and I will take it from result, and I will need to use something like response. And then what is it? It is response here, and then it is service ticket. Okay. Go. Then I will do command print again ticket, and now I should have this service ticket printed nicely in my console in the very end. Okay, cool. So now I have my ticket, and I can start using this ticket to make other different requests to the API service. I'll try to type everything. Let me first do, I think I should be able to just paste it. Yeah, there we go. The next API call I would want to make in this demo is request a list of network devices. And again, I will need some headers. I will need some, I won't need data for this request because I'm not sending any information. I only want to receive information. But for headers, it is very important. I will need to send this header a XAuth token providing this ticket variable or this ticket value, right? And I will need to use /network device API. And if I run this code, let's see what I get. Well, actually, I do get information about the network. You see the data structure, it has all the information, it has device IP addresses, it has all the basic and even not so basic, or sometimes pretty detailed information about all the devices. in the network, which are known to the controller. Okay, so we get the list of all the devices, and just yet another piece of code just show that additional lines of code. I can grab this data result and go over this data with a simple print command and print hostname, serial number, and software version for each device. Okay, once I run it again, see the bottom is a very nice and tidy list of network information. So I have device name, I have the serial number of the device, I have the software version. I can, of course, add any other devices. I can do whatever with this information. I can save this information in as a CSV file or any other file, or I can process this information in any way I want. One more thing.
Eugene, sorry, can I interrupt you? I just wanted to highlight that the poll is open for already 5 minutes, and it's about 5 minutes left to take the poll. So, dear attendees, those of you who haven't taken the poll yet, please, you can locate the poll in your WebEx event screen, or if you're using mobile device, in the chat you have the link to access the web version of the poll. So could you please take it and let us know also your experience, if you have some additional feedback about the technical experience on this session. Well, I guess excluding the audio issues, because it's we understand why it happened. Please also let us know in the additional comments. Yeah, thank you very much. And Eugene, back to you to continue and finish.
Yeah, thank you so much, man. Indeed, this audio breaking on my side, as well as packet tracer crash, this has nothing to do with this new WebEx we are trying to work with and experiment with. It's basically my computer to blame. It's getting pretty old. So okay, what we did so far, we got our service ticket for our further requests, and we did yet another request to get the list of network devices from the network, and we have even printed this list of devices with their serial number and a software version in a very nice and easy to use list. And final thing I wanted to do here in this example is to actually kind of apply some configuration to the network, not just read information, but write some information into the network. Okay, I will again paste yet another piece of code here, and let us look together at this code and understand what it does. So this is the API call to update network-wide syslog service configuration. You can do the same with DNS or NTP or whatnot. Any other things we have been doing with network controller, right? But for now, we will just for headers, in this case, I will still need to provide my XAuth token header with the ticket value. And I will also need to provide content type header because I'm going to send some data to the server. And this is the data I'm going to send. Data will be syslog. And syslog is actually a list of IP addresses, services I want to enable syslogging for. We already have this one configured on all the devices. So if I will jump again to where we were on R3, run include logging. So this one, .100, this is already configured. But I want to add one more, like 111, right? And I can add, I think, like as many of them as I want, and I can actually also add NTP servers. I can do whatever. Then I request because a put function implements the HTTP put method, which updates some data entry on the server. And that's what we want to do. We want to update under WAN network-wide settings. And I'm providing headers and data, and then I just execute. The last thing, I will not do this sprint. So the last thing we should see is actually the status code of this request. If it is 200 something, then it's okay. So let's run the whole thing. Of course, it will run also all the code that was done before, but we will just ignore that. $200 we have in the end. That means that our request was successful. And if I now jump back to R3 and we'll do the same command, we have the additional syslog service configured. It is pretty easy. It's as easy as that, right? To run these requests in Python. And one cool thing about that, just for all of us to realize, is you can actually you can write Python code in Packet Tracer. You can launch this code, and this code can interact with devices inside Packet Tracer or inside all these metrics of simulation. But there is even more than that. What else I can do, or you can do, you can actually, in this Packet Tracer for network automation, you can interact with this network controller API from a real world. You can write your Python code on your real computer and interact with this simulated network controller, making some requests. Let me demonstrate that. What I will do, I will simply copy all my here. Say let's not take the whole code. Let's make it just the read part. Okay, just the read part. This one, and I will copy that. Copy, and then I will start my here, or I could start any kind of editor for Python. And I will just create a new file as Python file, because Visual Studio Visual Studio will need to know IPD PTNA, let's say like that, .py, and paste the code here. Just which was copied from Packet Tracer simulated. Just thing, just IP address. Even this is just internal to Packet Tracer. This is part of the simulation, but I will need to change that, and I will need to change that to PT controller. So I'm just clicking the PT controller itself. Under config tab, there is this real world section. And if I go to this controller, I can enable access from the real world to this PT controller. So what this setting does, it basically exposes on port 8000, it exposes the same API interface. It starts a real server. This is not like a simulated PT server. This is a real HTTP server, which Packet Tracer application starts on your computer. And now you should be able to connect to that. Actually, and then I think, what was it? It was API/v1. I think this is it response. Let's try it anyway. I think response from the server, it's not supported this way. Where is my Visual Studio? And I will just type here local host on 58,000. And then I should be local host 1000 API. let me, yeah, and I will just load. Network. Python. The thing is, I just change the base URI and everything works, right? Okay, so that's it for the demo. Okay, that's for the lab equipment for DevNet Associate course. As you know, in DevNet Associate course, all the resources are provided inside a virtual machine, right? And that's why I'm using this Linux virtual machine. And this PTNA currently available only in this virtual machine. You cannot grab Packet Tracer 7.4 T version. You cannot install it on your computer. You can, however, use this virtual machine. You can download it and you can use this special flavor of Packet Tracer inside this virtual machine. And you will get your networking as usual in Packet Tracer, but you will also get this additional PT controller device with SDN and APIs and all the cool stuff. Yeah, again, this is part of the DevNet Associate course, and you can get yourself trained for this course. There are two options to become an instructor for DevNet Associate course. Option one is kind of classic ITC-based value-added course, and there are ITCs who offer this training. Find ITC near you and sign up for a training. And there is also option two, which is an online self-paced training only course. This way you can go yourself through the DevNet Associate course, and it will also include SDN, APIs, and coding. That's pretty much the concepts we covered in this session. And as well as there will be Packet PTNA labs in the course. There are two labs. I have used one of them as a base for this demonstration. And then after you complete this course, you will need to acquire your instructor accreditation for the DevNet Associate, and there are two options to do that, either ITC remote proctored final exam, or you can go and do the industry certification. And each of the options provide you a different set of benefits. Okay, I don't want to go too much into details of that. Just final thing I wanted to mention that you can get DevNet Associate instructor resources under resources, course resources on netacad.com, as well as the self-enrollment link for this instructor self-paced course. If you go to this page, you click this you just go to this page, you scroll this page all the way down, you go through this information. This is a very important information on this page. Familiarize yourself with it, and then on the very bottom you will find this instructor self-enrollment link into this course. Then you can go into the course and you can experience the DevNet Associate course and this PTNA and play with it, maybe build something really, really cool. I think possibilities are really great here. All right. For this session, thanks everyone for your attention. Sorry for a couple of glitches we had during the session. I don't think it's a big issue. I'm going to stop the recording right here, or